Welcome to another video. Today we are going to map carbon monoxide concentration in the city. So the first thing we need to do is head over to code.earthengine.google.com, then create your account. So here in the search bar we are going to search for carbon 2 oxide or CO. So just type in CO. After that we are going to select the Sentinel 5P NRTI-CO near real-time carbon monoxide. So if I click on this one, we can see the description. It says NRTI/L3CO. So you can read through this description and try to know what this data actually entails. So you can see we have the product and the description, the Sentinel-5 precursor, and everything you need to know about this kind of data set, and also the time it was launched. So this is 13th October 2017 by the European Space Agency to monitor air pollution. So we are going to look at the bands. So you can see the band table. We have the name, the description, the minimum value, maximum value, and the units. So we are going to deal with this one, this band, CO column underscore number underscore density, which describes the CO concentration column density, and the minimum value is negative 279 and the maximum is 4.64. And also take note of the units, these moles per square meter. So what we are going to do is copy this, then close, come to the script and say var collection underscore, because we want to look at the concentration in 2019, I can say underscore 2019, then I say equal to and paste the link for the dataset. That's ee.image collection Copernicus S5 / that one. Okay, so here I'm going to save. So I click on save and give it a name. I can say CO underscore concentration, and click on OK. Now what I also need to do is to import the shapefile for the area of study. So I come here to the assets. So here on the left panel we have the scripts, documentation, and assets. So I go here to, because I want to work with this, so I click on this icon, then it imports the table. If you don't know how to upload these kind of data sets here, I have provided the link in the description where I show you how you can import these shapefiles from your local storage to Google Earth Engine. Okay, so I can rename this to, I can leave it, or I can say this is Nairobi. Click on enter. So the next thing is I can start to filter out this data. So I can say tab dot select. So I'm going to select the column, so the band, I mean. So I'm going to select this band, this one. You can type it if you want, and because I don't want to encounter any errors, I just have to copy that. Then I say dot filter date, so filter date, and these I want to filter from 2018 December 31st to 2019 December 31st. So that's a period of 1 year. And then I say dot filter bounds. So I say dot filter bounds. This refers to the area of study. So I can just copy this one and paste it here, right? like so. Then the next thing is to get the mean, because we cannot work with the whole image collection. So you just want to pick the mean of whatever the data set that is there. So I say var co underscore 19. No, I can say co mean underscore 2019 is equal to, then I take the collection, so this one, Control V, and then I say dot mean, that way, right? Okay, so that way I have already gotten the mean. So I move on to visualization. I want to visualize this data, so I can say var vis params equal to this is an object, takes the minimum value as 0, the max value some, you can say 0.1, then the palette is an array of colors, so I can say green is green, the next one is cyan, then you can pick yellow, and the last one is red. Okay, so the next thing is to add this information to the map canvas. So I say map dot add layer, then what we are adding is the mean, so add mean, Control V, dot, we want to clip to the area of interest, so I say Nairobi, then we input the visualization parameters, or we can say these params, and then okay, instead of this one I can just put the curly brace and then give it a name as CO mean concentration 2019, right? I click on save and then click on run. Okay, I think it is going to add, but we need to define the center object, so I say map dot center object, this should be lowercase, center object, and this one picks the area of study, so Nairobi, comma, at the zoom level I can say 10, right? Save and run. Yeah, so this one takes us to the area of interest, so you can see this is Nairobi here. Let us wait as it loads. Okay, so we can see a black image. Let us try to visualize, so click on this settings icon, then go to, you can see we are using this band. I think we can stretch to 100, apply. Let us see how it looks like. So close. This is how it looks like. We can define colors. Okay, So I think we can define the color palette. So click on color palette, and the first one you're gonna choose is the green. Click on OK. Then the next one is cyan, some kind of that one. Then you can pick yellow. Okay, and then red. Then you can stretch to, let's say, 98, and then apply. So let's try that one. So you can see we're having this one here that is showing the concentration. So the one with red is where the concentration is higher. So I can import this. So I go back to the settings and then import the visualization parameters, close. So I can copy this, Ctrl C, scroll down, remove the curly brace and paste in the image visualization parameters. Click on save and then run again. So hopefully this is going to apply the color palette to the image, which is very nice. Now the next thing is we would like to visualize this using the histogram or the time series chart. Okay, now so to do this, what you are going to do is define the colors, because we want to display the legend here and the units for the concentration of carbon monoxide in the air. So to do that, we need to, okay, I can say defining concentration levels, level range. I can say level ranges and corresponding, and their corresponding colors. Okay, so I say var concentration levels equal to, so I can say this is concentration levels equal to, so this is an array 0, 0.01, 0.02, then we go to 0.03 and then 0.04, right? So these are the values we are going to use for the range from 0 to 0.01, 0.01 to 0.02, 0.02, 0.03, 0.03, 0.04. Then we are going to use this to generate histogram and the time series chart, and then also we can use to create the legend somewhere here. Okay, so also I can define the colors. So I say variable colors equal to, this is the same thing, we say green. The next one is cyan. The next one is yellow, and then the last one is red. So this means that from 0 to 0.01 we are going to assign it as color green, from 0.01 to 0.02 cyan, 0.02 to 0.03 yellow, and 0.03 to 0.04 as red. So that means the highest value in our concentration level is going to be color red, and then the lowest one is green. Okay, Now the next thing is to define the legend. First of all, we need to define the legend, so I can say define the legend or create the legend, whatever you want to name. So I can say var legend equal to the UI.panel. This is an inbuilt function for Google Ad Engine. When you want to create anything on the UI, you use the UI dot, then the panel could be either on the map or the somewhere on the interface. Okay, so you have to customize to the specific place you want to put the UI. So I want to pass in the styles, so I say style, and I can now decide to position. Say position, and so where do I want to put this legend here on the map? Maybe at the top, the bottom right, bottom left, yeah, whatever. So for me, I'm going to choose bottom dash right, so somewhere here, bottom right, yeah, okay. Then padding is going to be 8 pixels. I can say 8 pixels. Okay, the next thing is to create boxes and colors. So the legend has things like if we come here and say search for legends in GIS, look at the images. So click on images, and you can choose on this one. It's just for the purpose of demonstration. Here you can see the legend. The legend normally has the colors and the description. So for us, we want to create these color boxes. You can see here we have this small box and the description. So I think that is what this code is going to do. So here I can say create and add color boxes to I think I can say color boxes with labels to the legend. You have seen the legend, right? I can say var, and here I can say legend title is equal to still UI dot labels label. This is another inbuilt function in Google Ad Engine, and the label is going to be CO concentration legend. I think I can remove legend and say this is going to be in moles per meter square, right? Yeah. Then I can say font weight. So this is the font weight is bold. So we want the title for the legend to stand out from the rest of the content. So we say that's bold. Now I say legend dot add the legend title. So I can just Ctrl C and then paste it there. Okay, so don't forget the semicolon. Save and then try to run. Let us see if we have added something to the panel. So let us wait as it runs. So you cannot see anything yet. So we can continue. Let's say because we have this, I think we have just defined where the legend should be, but we haven't added any content yet. Now we want to add this concentration levels and color. Now the thing is, if you want to display this range from 0.00 to 0.01 to this and assign it this color, then take the next one to this color, the next one to this color, and the rest. I think here we need to use we need to loop through this as we loop through this and assign them these colors. Now we need to use the for loop to do that. So I can say for var whatever the value is, that is I, starting from 0, then we take this I, then we say it is less than or equal to concentration levels dot length, then we subtract 1, then we say I plus plus. So what this one is doing is that we are looping through these concentration levels from I, which is 0, to the length of whatever the values in these arrays are. Yeah, so we take the concentration level dot length, which we have 1 or 0, 1, not 1, 2, 3, 4, and 5. Then we subtract 1 so that we get the range from 0 to 4. Yeah, since we have colors from 0 to 3, and these are four colors, but for us here we have 5, so we should subtract 1 to get the range, since we are going to work with the range. I think that's why we're subtracting 1. Then we say var, so we define the color box, so the color box, which equal to the UI dot the label, this one is a method. Then in here we still passing the style, so we say style, so this is an object, and we say background color is going to be colors starting from I, then padding, we say this is 8 pixels, and margin is 0 pixels, top right 4 pixels, then 0 pixels on the left. Then the width of the box going to be 25 pixels. Okay, then still inside this for loop, we define the labels. So say var label equal to the UI dot label, then you say value. So the values for the labels is the concentration. Concentration is bringing a problem. Concentration dot levels from I. Then you say to fixed. So to fixed is a method that is used to convert or to fix the decimal places that you want for your values. So here I want to fix up to 2 decimal places, so we only have 0.00 or 0.00, 0.01, 0.02, 0.03. Then we concatenate this one with the concentration levels I. So I, then we add 1. So if we have 0.00, we add 0.01 to move to 0.01. So from 0.01 add 1, 0.02, then 0.02 plus 1, 0.03, up to 0.04. Then we also say dot fix, to fixed to 2 decimal places. Then we say style, and we say margin is going to be 004 pixel 0, not 0 but 6 pixels. Okay, so the last thing is to define the item. So we say var legend item equal to UI dot panel. So we are going to take in color box and the label, right? So we are going to take in this color box and the label. Instead of adding this manually, so we're gonna define a variable which to add to the map or to the legend, we only pick this one instead of trying to figure out how we are going to add all this to the legend. So we say the UI panel is going to pick the color box and the label. Then it says UI.panel dot layout dot flow is going to be horizontal, right? So what this means is that we are having the concentration levels as this from, so it is going to be, let me just write it here, 0.00, 0.01, 0.01, 0.02. So this code, this line here, is performing this. Then for the horizontal, if we have the legend as this one, you can see we have the colors on the left and the description on the right. So this is what it is saying, that we have the horizontal layout. So they are all aligned horizontally. For the 0.00 to 0.01 is going to be this color, which we defined here as green. So this is what it does. So for us, we are going to take this one and then add it to the legend. So down here you can say add the legend, add the legend to the map. But before that, we need to add the items to the map. So we can say legend dot add items to the map. Then after that, we need to say map dot add, then we pass in the legend. This legend is the legend that we defined up here, this one. That's why we didn't see it for the first time when we executed this code, okay, because I think we didn't add to the map down here. So now we can click on save and then run. So concentration levels is not defined, line 51. I think I misspelled these concentration levels. I can just copy concentration, this one, concentration, click on save, then run. Okay, so you can see you have the carbon monoxide concentration in mole per square meter. The greener is from 0.00 to 0.01. Then the cyan 0.01 to 0.02, 0.02 to 0.03, the yellow one, then 0.03 to 0.04. So this is the highest concentration. And if we try to switch this to satellite, you can see if I zoom in, this area is the CBD of the city. I think that is why we have a lot of carbon monoxide in the CBD, because of the vehicles and maybe industries in the CBD. So if I check this, you can see, let us wait. You can see here in the CBDs where we have the higher concentration of carbon monoxide. Yeah, okay. Now I think the next thing is to create the time series chart for better visualization. So I can say create time series chart. So here we define the chart equal to ui dot chart dot image dot series then this one takes into the parameters of image collection. So we take the image collection, so we say collection underscore 2019. Let me see what we named up here. I can just copy this one to avoid errors. Control V. Then we can continue to the region. So the region is the area of interest. Then we can also define the reducer function. Reducer ee dot reducer dot min. Then the last parameter is scale, which we can set to 1000. Okay, now the last thing is to set the option. So set the options. You can say chart. So we take the chart, and then we set options. So it is like we are defining some of the content to add more information to help us interpret the data much better. So here I say the title of the chart is going to be CO concentration 2019. Then the vertical axis or the horizontal axis, so which is the x-axis, whatever we are plotting against is going to be date. Then the vertical axis, it is giving me an error here because of the okay, yeah, that way. Then the vertical axis is can say title, and this is going to be CO concentration. So we are plotting CO concentration against this time. So if we have on the vertical axis these values 0 0.00, 0 0.1, 0 0.2, 0 0.3 up to 0 0.00 7 or 8 against date, so from January to December, or December 2018 to December 2019, because that is what we define up here as the date. Okay, now I think the last thing is the line. So the line width, you can say 1. Then the point size, we can give it 3. Okay, so whatever is remaining is to add the items or to print the chart. So we can say print chart, right? So make sure you save, then run. So generating the chart. Okay, so this is what we are getting here. It looks like something is not working fine, but at least we have gotten the time series chart, and we have the title, the CO concentration. You can see from 0.01 to 0.04. Then we can also see the time from January 2019 to December 2019, but of course we started from December 2018. Okay, I really don't know why it is not printing out the point size. Oh, the size should be capital S. Okay, save and run. Yeah, now this one looks much better. So you can see the point size and the line width. So you can see from October 1st, 2019 had the highest concentration of carbon 2 oxide with the 0.039 moles per square meter, and I think the lowest is 0.02. Okay, now the next thing is we can generate a histogram, which is used to show the frequency values that will help us to visualize the distribution of CO concentration, and it will also help us understand how many data points fall into different concentration ranges, like how many data points fall within 0.00 to 0.01. Yeah, and this one will provide insights into the occurrence or the density of carbon monoxide concentration values within our data set. Okay, now what we need to do is to create a histogram. So here we can say var histogram is equal to the UI dot chart dot image dot histogram, and this one is almost going to take the same parameters as this, but with a slight difference. So you can say the image. Now the difference comes in when you are printing the histogram and the time series. The time series, we define the image collection because this is the chart.image.series. It takes the image collection, and that's why we passed in collection 2019, so the whole image collection. But for the histogram, we are only defining one image, and this is the mean. So whatever the mean we got up here, this one is whatever we are going to pass in for the image, because this one comprises of a single image apart from the image collection which has all the images. Then we say the region, of course, is going to be the area of interest, and then the scale. The scale, you can put this to something like 10. The maximum buckets, these are the bars that the histogram is going to generate, so it can go up to 30. You can say 30, 20, or 50. Okay, the same thing as we have done here, we're also going to do for the histogram. So setting the options, so I can say setting the options for the histogram. Comment that one. So I can say histogram dot set options set options then you can say title is going to be CO concentration histogram, CO concentration histogram. Then the horizontal axis is going to take in the title as CO concentration, and then the vertical axis, so whatever we are plotting, vertical axis, the title is going to be the frequency. Remember, I've just said that the histogram is going to produce the frequency values that will help us to visualize the CO concentration, and will also tell us how many data points fall into what concentration range. Then another thing, it will tell us the occurrence or the density of the carbon 2 oxide concentration values that we have in this data set. That's why we are going to label it as the frequency. So we are plotting the frequency against the concentration. So if we have frequency, let's say frequency of 10,000, so maybe the data points have occurred within the pixel 10,000 times. So we look at the horizontal axis. If, for example, from 0.01 to 0.02, how many of these data points, what is the frequency of these data points within this range, or how many of them occur in this range? So that is why we are defining the histogram. Then what is remaining is now to print the histogram itself. Okay, so after that you click on save. So make sure you put the semicolon, click on save, and then run. Okay, so you can see here we have the frequency and the concentration. You can see for 0.026 moles per square meter, they have occurred 42,000 times in that range. Then the highest is 0.027, which occurred 870,000 times. So this is the frequency of the data points, and it shows us how many of them occurred within that particular range of the concentration or the density of the carbon 2 oxide. Okay, so this is it. Another thing is that you can enlarge this one, and you can also download this data as CSV, SVG, or PNG. If, let's say, you're working on a project and you want to include this image, maybe apart from taking a screenshot or snipping the contents, you can still download the PNG, and it comes with all the contents that you want. You can still download this CSV here, then open it in Excel, and you can still visualize this using Excel. For example, you can highlight all this data from December 2018 to December 2019. You can now insert the kind of histogram you want. So this one, or let's say maybe this one, and it will still produce the same results. You can see. Yeah, so this is visualization, but we have seen how we can map the concentration of CO in the city. For us, we can see the CBD shows that it has the highest concentration of carbon 2 oxide and the areas outside, especially this one. If we switch to the satellite view, we can see that whatever is perhaps contributing to have the lowest concentration here could be this kind of vegetation here. So another thing is that you can calculate the NDVI, or maybe use land cover using different machine learning algorithms to come up with the longitudinal curve of this area and determine maybe if you want to know for how long has this been occurring. Yeah, so this is it. Thank you for watching. I hope you enjoyed and you learned something from the video. Don't forget to subscribe and also leave a comment, and thank you. I'll see you next time.